Hi everyone, my name is MAvis. I'm a computer engineering student enrolled in ECE 311 and 331. Knowledge Integration 1 is about the power supply system of a cell phone. So we will be breaking down the subsystems of the power supply system and then looking at how they go together to form the power supply system to see what it does. So here's the circuit for power supply system. It has two subsystems, a rectifier and RC circuit. The purpose of the system as a whole is to take an AC signal as an input and convert it to a DC signal at the output. The rectifier subsystem is nonlinear because it does not satisfy additivity or homogeneity, whereas the RC circuit subsystem is linear because it does satisfy both of those properties. Both systems are time invariant because any time shift at the input will produce the same time shift at the output. Therefore, the combined system is also time invariant because both systems are, but yet the combined system is not linear, so nonlinear, because the rectifier subsystem is nonlinear. So the rectifier subsystem consists of a full wave bridge rectifier, which is 4 diodes arranged so that during the positive half cycle of an AC input, 2 of the diodes are acting as on, and during the negative cycle of the input, the AC input, the other 2 diodes are acting as on. So the input here is Vin of T, and the output is Vrec of T. Using ideal diodes, this Vrec, the output of the rectifier, will just be the absolute value of the input. So if you have a sine wave, we'll see on the next slide. For non-ideal diodes, your output voltage from the rectifier will be your input voltage minus 2 times the threshold voltage, which for diodes is typically around 0.7 volts. So using a sine wave as your input, sinusoidal wave, is labeled in red. You have the blue wave would be the output with ideal diodes. So it would be always positive. The negative half cycle turns into positive output. Using non-ideal diodes, you can see that anything below 0.7 volts will output 0 volts because it is below the diode threshold, or 2 times the diode threshold voltage. So talking about 331 concepts a little bit, how a diode works, a diode consists of 2 sides that are positive and negative charges. There's a depletion region between the 2 sides, and as an electric field is applied from one side, so on the top image you have the electric field going from left to right, that will decrease the depletion region, which means that the diode will allow current to flow from left to right. Whereas during reverse bias, if charges are flowing from right to left, the depletion region will increase in size and width, becoming more insulating and less conducting, which means it will oppose the flow of charge up to a certain point, which is the electrical breakdown point, or so the smoothing capacitor side, the RC circuit subsystem is essentially a smoothing capacitor. It takes the voltage from the rectifier as an input, and using Kirchhoff's voltage law, you can derive the equation for that output, and using that equation you can it can be shown that it does satisfy linearity, both additivity and homogeneity. You can add an x1 and an x2, and your output will also be y1 and y2 added together correctly. Same with homogeneity, you can scale x1 and y1 will be scaled as well at the same amount. Time invariance, it is also time invariant. A shift in the input will produce the same shift in the output. If we're given, in the pre-work, we were given vrec to be the unit step function. So using that, you can find the unit step response of the smoothing of the RC circuit as S of t. And then you can also take that unit impulse, or you can take the unit step response and find the unit impulse response by taking the derivative of S of t to get H of t, which is shown here. Using the unit impulse response along with the Vin of the entire system, normally with a time invariant linear system, you would be able to use convolution to find V out. However, because the rectifier is not linear, it's not as easy to do that. The way I believe to do that would be piecewise, using taking threshold voltage if you're using non-ideal diodes to convolve the input when voltage is above 0.7 with, and only on the positive half cycles, with this unit impulse response to find the output during positive half cycles, and then do the same thing for negative half cycles, I believe. Otherwise, as a whole, the total system, using sinusoidal waveform again, the output of the system would look something like this. You take your rectifier output using ideal, again these are ideal diodes, be positive waveforms, and then the smoothing capacitor would build up, each cycle would build up charge and then slowly discharge, carrying over to the next cycle, gaining a somewhat smooth output, which can be equivalent within, plus or minus some voltage, which is your ripple voltage, and that is similar enough to DC, so there's AC to DC conversion. Alright, that is my presentation. Hope you guys learned something that you didn't already know. Maybe, I don't know. Thank you for watching either way. Good luck this semester. Thanks.